Hey everybody, thanks for clicking on my first video ever on this channel. I love your growing support. Today we will be introducing and exploring the concept of vectors. In simple terms, a vector is just an arrow, where its size corresponds to its magnitude, and the arrow itself gives the direction right here. It is also worth noting that a negative vector points in the opposite direction to a positive vector. Vector can be split into its x and y components that create the resultant vector. So we have our resultant vector here, our x component here, and our y component here. Having the resultant vector of r, its x component would be rx equals to r cos theta. So this right here will be r cos theta. And its y component will be r sine theta. This right here will be r sine theta. This comes from the idea of SOHCAHTOA. That being, the adjacent side from the angle, so from this angle right here, the adjacent side has a cosine relationship with the hypotenuse, or in this case, the resultant. That is, the adjacent side right there, and the resultant right there. And the opposite side from the angle, so this side right here, has a sine relationship with the hypotenuse, therefore r sine theta. Why this is important is because it will come in very handy when attempting complex projectile motion problems later on. For 3D coordinate systems, we extend this idea to include the third axis, known as the z-axis, which is directed upwards as shown in the diagram. To write any vector in this system, you would separate its coordinates into its x, y, and z components, and then you would write it in this form right here. In which this is the magnitude of the x component, this is the magnitude of the y component, and this is the magnitude of the z component of the overall resultant vector. The last thing we will look at before we finish our introduction to vectors is how to find its magnitude. Alright, so to do this, a simple application of the formula magnitude of vector r is equal to the square root of the r x component squared plus r y component squared plus r z component squared. All you do is you simply substitute each component into this formula, and that will give you the overall magnitude of the entire vector. Practice example building on this idea. The example we have is find the magnitude of the vector 3, 4, 5. So first of all, we should write down our formula. So it's the square root of the x component squared plus the y component squared plus the z component squared. Now all you do to find the overall magnitude of this vector right here is sub these components in. So that will be equal to square root of 3 squared plus 4 squared plus 5 squared. Now if we simplify this, we'll keep it in exact form, we get root 50. I hope this introduction to vectors was useful for initiating your understanding on this topic. And once again, a big thank you from A-Academy on clicking on my first video. It means a lot to me. See you guys later.